Hey everybody, this is Brad Dyke. How you doing? I'm hoping you're doing great. We have had this big, huge winter storm front come through, and now we're supposed to get -5 degrees out here and all that good stuff. But my lab is warm because I've got all the firepower in the world for that, and 80 amps to back it to prove it. But anyways, I digress. So today's video is about one of the 3 projects I was going to do, and that is preparations wise from the hardware into the resourcing, and then bring a brand new set of ProxMox clusters online, both in a high compute value, which are going to be 2U's over here, and then those little boxes you see up there at the top, the 7040 disks, the 7040 PC arrays. Those are going to be transformed into a minor ProxMox cluster so that I can leapfrog some new features and functionalities in the latest release of 8 for ProxMox versus 7. So with that being said, let's talk about the hardware first. Okay, so what we're doing basically is we're looking at this guy right here. He is an HP DL380 Gen 9 platform with 4 stripe drives in a RAID 5 configuration right there, and a RAID hot swap drive right there, and this one is hardware RAID configured, and it is a system I built. I bought several components like this one down here to help build this one into the series 24 series 2, and this is going to have a Gen 4 series dual processor setup with the 6 gig SAS configuration using the SATA SSD drives, and it's a ProxMox node cluster with 192 gigs of RAM, and its overall functionality is going to be really good in regards to its ability to handle a pretty fierce high-end style ProxMox clustering design, like 4 quads and so on. I can do that here with that. Now its brethren is going to be down here, and this is not what it looks like. It's not a 7810 or a 7910. It's the chassis of a 7910, but it has actually inside it, and you can see it here, a PowerEdge R730. Now, not an XD 730, because an XD looks like this. This is an XD. Lots of discs. Now this one does not. This one's got the media station for multimedia communication, and it's got the bridging for a DVD drive, and it's got discs, but not a lot. Just 2 sets of 8. And I have its brethren right here, which is just strictly CPU processing mode, and he does something similar as well. But this one here, the 730 and the DL380 Gen 9, will be rebuilt and repurposed for that configuration. So the key thing on that configuration side is, what am I working with here? Well, first things first, obviously, I've been checking the biases to make sure, not necessarily that I have the latest and greatest biases, but I have the most stable based biases. And I'm basically setting up my configurations in such a way so that I can do what I want to do and have the necessary resources. I've got 88 gigs on this unit. I have 192 gigs on the other unit. So this one is going to be for my secondary minor platforms that will have consistent of 6 to 8 gigs maximum per each instance, while my 192 will carry the 16s, 8s, and 32s. So that's a pretty good mix, and I've got it configured in a pretty clean format. Now, just to give you a reference on the DL380, let's go ahead and flip over to that. So I'll go ahead and flip the configuration screen for that, and we'll power it up. And there she goes. I always thought it was pretty interesting to see how they do that formulation for the LED states of the drives. But it's pretty cool either way, so it's not a big deal. So my KVM switch is up here. I'm switching over. I only need an 8-port KVM, even though I have many more than 8 machines here. I rarely ever use keyboard, video, and mouse once I initially get things set up. So that machine is posting now. So we'll give it a second here to do that. Okay, so it's booting up now, and the BIOS release revision is correct. That's what I want to see. And now we're going to be switching into the display state of the system. We have 192 gigs of RAM, right there it says. And it's got the Series 6400 processors. And that's going to be the 2680s, specifically the E2680s right here. The 64 series set is mostly driven on the chipset, so we're in good shape there. My stack is 9.6 gig per second, and I've got it staged and balanced for resourcing. Now this machine already has the ability to boot ProxMox, but it's on version 7 point. And we are going to take this up to a newer version. There's still a couple more things I need to do. So, when you're dealing with processor stacks, such as the 2600 series processors, which is what these are right here, these are version 4s, which will be going into the new AI node build out with the Supermicro platform, and of course lots and lots and lots of memory. So I'm going to be balancing this particular cluster in interchangeable states, and to be able to run the cluster node itself, which is basically the general ProxMox environment for the cluster, but I'm not running failover modes. The reason why is because we're poor, right? We can't afford to have two of each class platform out there. One is a backup for the primary for the heavy hitters, and one from a backup for a primary for the medium grade hitters, and then you've got the little boxes over here for the little stuff, like containerization and so on. So I'm going to be doing it in a slightly different format. I'm going to have a higher end resource pool, same stack processor set, and then a lower resource pool, same stack processor set, but in reduced usage models. In other words, they're going to be smaller, more fiercer, intenser instances for tasking based, like running with Rocky or Alpine, and work with those components. Now, the goal of this is to give me a fast deployment of either the high ends and the medium ends to emulate that of what you would see on an AWS cluster or Azure cluster or Google cluster. The miniatures over here are helped to emulate services that you would see in hybrid cloud or cloud type level services. So that gives me the ability to build my simulation engine a lot more effectively in my test bounds, my test inbounds versus my outbounds, and so on. What's the goal of all of this? To do it agnostically. You see, cloud providers need you to link into their services, get hooked really good, so it's really painful to step away. Well, any operations environment worth its salt would not make that mistake. Yeah, you do kind of have to use some of the services, but you knowing for sure in the back of your head that at the end of the day, it's got to be on your operating system that you can restore anywhere in the world. All you need is compute resource. It's got to be a fairly uniform open source style database that you can rehost anywhere, that you can back it up and take it anywhere, and so on and so on. Rinse and repeat. Services that are not proprietary, dependent on specific services or sub-services that only the provider provides. You don't want to do that mistake. So I need something that's going to be able to do that, and my 7 was kind of a fragmented, let's do clustering kind of deployment, wasn't optimized like I'm doing now. So I'm looking at the actual resources, I'm looking at the 10 gig pipes, rebalancing the 1 gig front ends, and just getting it to a better place so that I know exactly I hit my node alpha for my quads and my 8-ways, I hit node Bravo for my 1s and 2s and 3s, and so on and so on, and then I can go out there and very quickly focus on the real goal, and that is those instances and or containerizations that are holding the real nuts and bolts of what we call business today. So with that being said, back here I've been working on restructuring the insides of those in an effective way so that I can kind of get that allocation a little bit more in line. And I did find out some things. Let me show you. Okay, so basically what we've got here is a cloud router, which is a CRS 208 style 8-port 10 gig switch setup, which you see right here. And this basically is a great switch. It really is. It's a great backplane switch. It's excellent for working with a two-tier infrastructure model. That means you've got your 1 gig architectures down here, and you've got your 1 gigs consoles here, and then you've got your back-end data plane for moving large sums of data between nodes, and that's on your 10 gig switch network. And then that allows you to create the 3 tiers that you want to see out there with the normal operations environment. Now you can also inject other switches into that equation, but something's not quite right here. And as I was looking, I first thought, well, I've got fiber GBIC10s, I've got hard copper 10 gigs, I got RJ45 10 gigs, but the performance level of these are actually at performing call correctly. So when I've got these 2 nodes in communication, I'm not getting quite the right kind of bandwidth down there as I should be seeing up here. So when I go in the back, I realize, wait a minute, I forgot I have another 10 gig backplane switch that is linked into my other 10 gig switch to give me 3 additional 10 gig ports, and that's really all you really need. So I got a fiber optic pair, so there's no CRC errors there. That's not an issue. I've got my 10 giggers here, they're straight copper, but I do believe I might know where my problem is, because when I look at this switch setup, this is the way it would look like normally, I have an active state switch, which is this second one here, which is showing right over there, along with my uplink. So if I pull this guy out, that's my uplink right there. And I put this guy back in, and that guy is going down to my Dell 730 down there. So I found my problem. So the problem is between the fiber pairing, one of these yellow cables, which I suspect is this one, and this guy right here is creating an additional latency effect from a 10 gig to a 10 gig, and that is actually showing about a 10% loss in performance, which is significant. So what I probably want to do is I want to offload some of my standalone high-end machines, like my databases, move them over to the other switch, bring that other ProxMox node up into here, and I'll see the brand new and more efficient transfer rates that I need to see, because it is taking quite some time to get some stuff done, faster than a 1 gig, but not like a 10 gig. And that's, I don't want to deal with that latency effect. So that's something I discovered when I was doing the teardown, that because I wanted the extra ports, I forgot that I've created a little bit of a latency gap between the 2 10 gig switches. Now down here, this switch, which is a this is the Juniper. It's got 10 gig interfaces as well, and they pair up and communicate openly, so that's not a big deal, and it does pretty well, but it's strictly for the front end, where this is the back end, and this is for the tiered or edge compute servicing, which I work with, and this is a much older style Nortel switch, a 6300 series. Pretty old, but it's an excellent switch. Really, really kicks butt. But it does have age to it, so I moved it down to the edge, and does pretty well. It runs all of my primaries, my secondaries, and my low-end ProxMox modules, and all of that. So what I've done now is I've reconfigured this box so that it's going to act as my controller. In other words, he's the best performer right now. But the 730 has got the more allocatable resource and bigger pool, so he'll have to be brought up to speed to match the controller. That was the problem with my old version of the cluster, that these had a 10 to 20% loss in performance between the 2 of them. And that's going to help me understand a little bit better on that front end. Now, these 2 guys right here are LDAP. One's LDAP and one is Active Directory services for denial of service attack pattern models that I can use to attack the services to simulate an outbound inbound attack. So these two are going to be part of this environment as well. And I've also got a Kali platform, which will also be used to attack a lot of these environments as well, and just kind of just kind of mess it up a little bit to make sure that WAF testing is going to work the way I want it to, and get me where I need to be. So the moral of this particular discussion is, when you start to work with ProxMox, just get a machine, get a couple of boxes, set them up, pair them up, learn how to cluster, blow it all away. Do it a couple times. Get comfortable with it, use the services, and just kind of get comfortable with the nature of taking resources, pulling them up into a cluster, and working them in such a way so you can get the end result you want. Now, with that being said, after you've done that, you need to step back away. Now, when you do, and you decide, okay, what type of ProxMox testbed do I want to do? Am I just the intro guy out there, and I want to do containerization and with some Docker and some GitHub activity and Terraform and things like that? I say gravitate to the Dell 740s. Keep it simple, small. Get 3 or 4 little i7s with 16 or 32 gigs of RAM in each of them, and 1 terabyte or 2 terabyte SSD drives. That's all you need. You're done. You might even set up a little NAS with an NFS share, so you can give a couple of terabytes of common storage across your cluster nodes, which is really great when you want to transition nodes from one node to another. That's the best way to do it. Once you've done that, blow it all the way again, and this time say, okay, what type of cluster do I really want to have, that I want to go forward with? The end result is, as you can see here, I have to have 2 different types of ProxMox clusters to get me where I want to be, and be able to really basically do some pretty heavy hitting, all the way down to some very light stuff, like running a tiny MDB on a container or something like that. Something easy, not a big deal. MDB files, or basically MariaDB databases, are basically very easy to kick off. Like same with MySQL and containerization, using Docker and Terraform, which is a great way to learn how to do that kind of stuff. And the end result is that you get yourself a fairly flexible model, hardware model, to fit your ProxMox instance. Then when they're done with that, it's time to pull out the USB stick, stick it in, and start building that cluster up the way you want. Remember that when you do that, if you're smart about it, you'll have a config dump file, which will give you all the information you need, including your credentials to sign in and secure your NFS connections. Those are important details, and I don't recommend you go hog wild with those unless you have special needs for ciphers, MFA, MDA style kind of connectivity, and all that kind of stuff that you can do and you can learn how to do, but at the same point in time, build as you need to learn it, and learn how to build is what I'm pushing at here. So with that being said, the overall strategy here is to get you to a point where now you're thinking a little ahead of the game. And if you've seen any of my other videos, you always find out that I will say something like, where's your pad and paper? That's right, a pad of paper and a pencil. Write it down. What do you want? What do you need? What do you want to learn? And so on. And then what you find out very, very quickly is a generic ProxMox is not a good answer for that. But a customized version of your clustering might be just perfect for what you want to do and save you money. That's the beauty of it. So that's what I'm doing here. I'm saving money. I'm taking a principal ProxMox cluster, but I'm going to try to bastardize it down into 2 variations, but working within one cluster, which means I have one that can absorb everything from the other, but I don't have that capacity to do it to the opposite side. So it means I have to also think, how far can I go with my big rig versus my smaller rig, and make sure that I'm coming out ahead of the game in case I have to, for instance, move 4 or 5 critical instances that are fairly large, and I have to power everything down on the smaller rig, move them over, but I am successfully able to transition that chassis away, bring in another chassis, add it to the cluster, bring it back up, redistribute, and so on. Those are great exercises to learn how to do as you're doing this process. The most important component about this is the same thing I preach all the time. Learn the protocols. Everything in this industry is written to the protocols. That's why you can have 125 vendors, but you only got one TCP protocol. See what I mean? So learn the protocols, understand the protocols, work with the protocols. You know pretty much, I don't care what switch it is or what platform it is or what firewall it is, if it deals with TCP, they've got to do X, Y, and Z for it to work correctly. It's the same thing with DCM for disk management. It's the same thing with ZFS. It's the same thing with DNS. It's the same thing over and over. LDAP, ADS, you name it. Learn the protocols. The world comes to your door. So with that being said, this is a pre-planning video. I've already prepped my boxes to be rebuilt. So I'll be doing that part later, and I'll be having my new ProxMox environments come in, and I'll show you what I've done. I'll add I'll add the secondary node into the equation from the primary node, show you how that's done with 8.0 release versus the 7.0 release. And that's pretty much it for this one video. I hope this gives you an idea. It is important to plan if you really want to optimize your success rate in your lab at home. Well, this is Brad Dyke signing off. God bless and take care.